喂，朋友，等一陣啦，前啲啦。唉，我好攰啊！我唔記得話俾你聽，我名係 Position Ninja。
I am Velocity Ninja. I am Excellent Ninja.
So, position is where an object is relative to time. When looking at the graph shown here, you can see an increase in distance over time. At the top of the function, the object turns around and begins heading back from where it came. When the graph plateaus near the end, that means that the object has stopped and the position is no longer changing.
Alright, so that's enough with the fancy calculus stuff. Let's get to the ninjas and see how this stuff really works.
哇，今日好熱啊！你想去跑步？冇啦，我哋去玩啦。
Velocity is position over time. Velocity is the derivative of position, found by taking the derivative of the position function with respect to t. In the graph shown here, the positive slope implies a positive acceleration, moving away from the starting point. The horizontal slope shows no acceleration. Then the negative slope shows negative acceleration, and when that negative slope crosses the x-axis, the object starts to head backwards. In that last part of the graph, the velocity heads back towards zero, showing the object is slowly headed towards rest.
Alright, so thank you Professor Will and Fu Yuk-sin, or Sunny Fu, for teaching us about the velocity graph. And now let's go over to the Velocity Ninja and see how he does it.
So, acceleration is a change in speed over time. Acceleration is the derivative of the velocity with respect to t once again. In the first part of the graph, we see a constant and positive acceleration. Then the acceleration hits zero, showing no acceleration or rest. When the acceleration is negative, it implies an object is slowing down. Much like a baseball tossed straight up into the air, hovering and falling back down to the earth. Then in the last part of the graph, we see once again a positive acceleration, then plateauing off, showing no acceleration or rest.
Alright, so that was the acceleration part of the graph. Now let's send it over to the Acceleration Ninja, who moves so fast, Sonic the Hedgehog will be jealous of him. Welcome to Position, Velocity, and Acceleration with Will and Sunny. Of course, I'm Will and Sunny working the camera right behind you. Let's get on to the teaching lesson of this bit. So, as you see here, we have the graphs that we had previously shown you, and this time we've actually sectioned off a couple of parts of the graph. If you look at the position graph, like I said before, we have just this slope, the constant rate right here, and then it kind of comes down, and then if you look into this section that we've quarantined off, it's actually a kind of parabolic section, and then of course we have the, again, flat slope. If you remember, a lot of this has to deal with integration and deriving. So position, once again, is the original one, or like the basic function, and then the derivative of that is velocity, and the derivative of velocity is acceleration. So if you want to look here at the velocity graph, this section that we've quarantined off, if you look here, this is kind of like a line that you would, probably associate with an x, or like y equals x kind of line. And if you look, and if you remember that the derivative of any like y equals x, so like 2x would just be 2, you see that this constant slope right here is just that flat line. The velocity is this constant slope, and then we have the no slope at all, so the derivative of a constant is 0. And then if you want to look at this section, if we want to go backwards, again, you integrate acceleration, you get velocity. So in this one we have just a flat line, like before, and we integrate it and we get the slanted line, the y equals x line relatively. And then if you want to integrate this one more time, you get this parabolic thing. I apologize for the drawing, it's not the best of it, but this is really supposed to be a curve. Little bit shallow, but a curve nonetheless, so that way you get that x squared function looking for it.
So the basic things we'll need to be doing motion graphs would be paper for writing, of course, and you either have a pen or pencil. I would use pencil because there's always mistakes at each. And then the basic skills you're going to need will be driving, integrating, and to make deriving a little bit easier, you're going to need to know the power rule. And just to make things a little bit more exciting, you're going to need how to do this. And here we have two section parts off of the graph. This line right here is relatively 2x. And you take the derivative of that to get the line, the equation for this line, which would be 2. And you can derive that again, and then we're going to get the next line, which would be 0. And remember guys, that pi is a constant, so just remember that. And here, on the second part of the graph right here, we're going to be integrating this constant, which is roughly 2. And you would integrate that, so it would be 2x. And then you would integrate that again to get x squared.
Action.
Wait, we started already? That the derivative of a constant is 0. And just to remind you, pi is not a constant, okay? Just remember that. And in the second do that again. You got to be like on there, dude.